Right now, across the planet, a force is building that most people have not even begun to prepare for. It is not a single storm. It is not a regional weather event that will pass through one part of the world and leave the rest untouched. What is developing in the Pacific Ocean at this very moment is a fundamental shift in the way the entire atmosphere of the Earth behaves. A shift that is going to reshape the weather experienced by billions of people across every continent over the next 12 months. And it is going to begin doing so with a ferocity that even the scientists who study these systems most closely are struggling to fully anticipate. The United Nations has issued its warning. The ocean buoys and satellites monitoring the tropical Pacific are sending back data that is making researchers stop and look twice at their screens. And yet, across most of the world, life is continuing as normal. People are going to work, planning their weekends, making decisions about the coming months, with almost no awareness of what the atmospheric and oceanic data is saying is coming. Nobody is ready for what El Niño is about to do this August. And by the time most people realize what is happening, it will already be reshaping the weather around them in ways that no forecast, no warning system, and no amount of last-minute preparation will be sufficient to fully address. Stay with me, because what is unfolding right now in the Pacific Ocean is one of the most consequential weather stories of our lifetime. And understanding it, truly understanding the mechanism, the history, and the trajectory, is the first and most important step toward being less unprepared than the rest of the world is right now. The Pacific Ocean covers nearly a third of the Earth's surface. It holds more water than all the land on the planet combined. And the temperature of its surface, the thin layer of water that sits in direct contact with the atmosphere above it, exerts an influence over global weather patterns that is difficult to overstate. Under normal conditions, the tropical Pacific operates according to a rhythm that has governed global climate for thousands of years. Trade winds blow steadily from east to west across the equatorial Pacific, pushing warm surface water toward Australia and Indonesia, and allowing cold, nutrient-rich water to rise from the deep ocean along the coast of South America. This upwelling cold water keeps the eastern Pacific cool. The warm pool in the west stays warm, and the temperature gradient between the two sides of the ocean drives atmospheric circulation patterns, the jet streams, the monsoons, the storm tracks, that deliver rainfall and regulate temperatures across every continent on Earth. It is a system of extraordinary complexity and extraordinary stability, and billions of people have built their agricultural systems, their cities, their water infrastructure, and their entire way of life around the assumption that it will continue to function within its historical parameters. El Niño is what happens when that system breaks down. When the trade winds weaken, as they are doing right now in August 2026, at a rate and to a degree that has meteorologists watching their instruments with undisguised alarm, the warm water that has been pushed westward by those winds begins to drift back toward the east. Sea surface temperatures in the central and eastern Pacific begin to rise. The cold upwelling along the South American coast weakens and eventually disappears, and the atmospheric response to these oceanic changes is immediate, global, and profound. The jet streams shift their position. The monsoons alter their timing, their intensity, and their geographic reach. The storm tracks that bring rainfall to some regions and protect others from excess precipitation relocate across continents. Weather patterns that billions of people depend on for their food, their water, and their physical safety become unpredictable in ways that the historical record, however imperfect, at least gave some framework for anticipating. El Niño does not merely change the weather in one place. It changes the weather everywhere, simultaneously for over a year. What is developing in August 2026 is not a normal El Niño, and the distinction matters enormously for understanding what the coming months are going to look like. The sea surface temperature anomalies being recorded in the Central Pacific right now, the departures from the historical average that define El Niño's presence and intensity, are at levels that, in any previous decade, would have been considered the peak of a significant event. But the event has not yet reached its projected maximum. The subsurface heat content of the tropical Pacific, the thermal energy stored in the water below the surface, which functions as the fuel tank that sustains and intensifies El Niño over time, is at extraordinary levels. There is a reservoir of warm water beneath the surface of the equatorial Pacific that researchers describe with words they do not use lightly. It is deep, it is extensive, and as it rises to the surface over the coming weeks, it will push the anomalies higher, sustain the El Niño through what would normally be its period of seasonal moderation, and extend its influence over global weather into 2027. The models, multiple independent modeling centers running different approaches to the same problem, are in strong agreement about this trajectory. And when models that normally diverge significantly in their medium-range projections converge this strongly on a single outcome, it is a signal that the atmospheric science community takes with the utmost seriousness. August is the month when this year's El Niño moves from something that scientists have been watching with concern to something that the rest of the world begins to feel directly. The mechanism by which El Niño translates from an ocean temperature anomaly in the tropical Pacific to actual weather impacts in places as far removed as the American Midwest, the African Sahel, and the Australian outback operates through the atmosphere at a speed that is genuinely remarkable. Changes in ocean surface temperature alter the patterns of atmospheric convection, the rising of warm, moist air that drives thunderstorm development and rainfall over the tropical Pacific. Those changes in convection alter the position and strength of the subtropical jet streams that circle the globe at high altitude. Those jet stream changes shift the storm tracks and weather patterns across the entire extratropical world, the mid-latitudes where most of the world's population lives and where most of the world's agriculture is conducted. The signal propagates from the tropical ocean to the global atmosphere in a matter of weeks, and by August of an El Niño year, that signal is already embedded in the atmospheric circulation in ways that are shaping weather outcomes around the world, whether those outcomes are being attributed to El Niño or not. The United States is already feeling the fingerprints of what is developing, even though the El Niño has not yet reached its projected peak. The heat dome that has been locked over the western United States for the past several weeks, the system that has driven temperatures in Death Valley to 126 degrees Fahrenheit and put 40 million Americans under active heat alerts, is being sustained and amplified by atmospheric circulation patterns that are consistent with El Niño's influence on the position of the subtropical ridge over North America. The extraordinary moisture content in the atmosphere over the central and southern United States that has been fueling the severe thunderstorm outbreaks, the tornado warnings, and the catastrophic flash flooding events of recent weeks is being supplied in part by sea surface temperatures in the Gulf of Mexico that are running at record levels that are themselves connected to the broader pattern of ocean warming that is both enabling and being amplified by the developing El Niño. What Americans are experiencing right now in terms of heat, storms, and flooding is not the full El Niño impact. It is the appetizer. The main course arrives as the event intensifies through the fall and winter months, and what it delivers to different parts of the country will be determined by where exactly the jet streams settle as El Niño reaches its peak. The winter outlook for the United States under a strong El Niño is one of the most well-studied and most reliably predictable seasonal forecasts in meteorology, and what it says about the coming winter of 2026 to 2027 is worth understanding in detail. Strong El Niño events consistently produce a wetter than normal winter across the southern tier of the country, from California through Arizona, New Mexico, Texas, the Gulf Coast states, and up through the Carolinas and the Mid-Atlantic. The jet stream shifts southward across the country, steering Pacific storm systems into California and the Southwest, and then tracking them eastward across the southern states. California, which has been oscillating between devastating drought and catastrophic flooding as El Niño and La Niña alternate, faces another winter of atmospheric river events, the concentrated corridors of moisture that can dump months of rainfall in days, filling reservoirs while simultaneously overwhelming drainage systems and triggering landslides on fire-scarred hillsides that have lost the vegetation that once held the soil in place. The northern tier of the country, the Pacific Northwest, the Northern Rockies, the Great Lakes states, faces the opposite signal with warmer than normal temperatures and below normal snowpack that will have implications for summer water availability that extend far beyond the winter season itself. But the El Niño impact that will matter most for the largest number of people is not what happens in the United States. It is what happens in the monsoon systems of Asia and Africa, where the timing and intensity of seasonal rainfall determines whether hundreds of millions of people have enough food and water to survive the coming year. The Indian summer monsoon, the single most important seasonal weather phenomenon for human welfare on Earth, providing the rainfall that over 1 billion people depend on for agriculture and drinking water, is one of the most El Niño-sensitive climate systems that exists. During strong El Niño events, the Indian monsoon is typically weakened. It arrives late. It produces below normal rainfall across large parts of the subcontinent, particularly across the northwest and central India, where rain-fed agriculture supports enormous rural populations with no alternative water source. It retreats early, cutting short the growing season at a time when crops are still in critical developmental stages. And when the monsoon fails or significantly underperforms, the consequences cascade through every layer of Indian society with a speed and severity that is impossible to fully convey to someone who has never witnessed a monsoon-dependent agricultural system under stress. The data coming in from the oceanic monitoring systems in August is telling a story that agricultural planners across India, Pakistan, Bangladesh, and Sri Lanka are reading with enormous anxiety. The sea surface temperature patterns in the Indian Ocean, which modulate the monsoon's behavior independently of but in interaction with the Pacific El Niño signal, are themselves running at anomalous levels that, in combination with the El Niño developing in the Pacific, produce a forecast for the 2026 monsoon season that is deeply concerning. Rainfall deficits are already being recorded across parts of northwest India and Pakistan. Reservoir levels in several Indian states are below their normal August levels, despite the monsoon season being well underway, a signal that the rainfall that has fallen has been insufficient to compensate for the evaporative losses driven by the extraordinary heat of the pre-monsoon season. Farmers across the Indo-Gangetic Plain, the agricultural heartland that feeds 1 billion people, are making planting decisions under conditions of uncertainty that have no good historical analog, because the combination of El Niño strength and background warming that characterizes the 2026 season has no precise precedent in the observational record. Australia is the other major region where the August signal of what El Niño is doing is already unmistakable, and what is happening there right now is a preview of what the Southern Hemisphere summer, which begins in December, is going to look like across a much wider area. Rainfall across northern and eastern Australia has been running well below normal since the El Niño signal began strengthening in the Pacific earlier this year. Soil moisture levels across the agricultural regions of Queensland and New South Wales are declining at rates that fire behavior analysts and drought monitors are watching, with the kind of focused attention that precedes the activation of emergency response frameworks. The grass across the pastoral regions of the interior is drying. The eucalyptus forests of the southeast, which carry the most catastrophic fire potential of any forest type on Earth when they are drought-stressed, are accumulating fine fuel loads that fire scientists are already describing as extreme. Australia's Black Summer fires of 2019 and 2020, which killed over 30 people directly, caused the deaths of an estimated 3 billion animals, and blanketed Sydney and Melbourne in smoke so thick that air quality monitors maxed out their measurement scales, occurred under El Niño and drought conditions that the current trajectory of the 2026 season is already approaching and may surpass. The question being asked in fire management agencies across southeastern Australia right now is not whether the coming summer will be severe. It is how severe, and whether the resources that have been rebuilt and restocked since 2020 will be sufficient to manage what is coming. The African continent presents perhaps the starkest illustration of El Niño's capacity to reshape the human condition across an entire region, because the rainfall patterns of sub-Saharan Africa are among the most El Niño sensitive on Earth, and because the populations most exposed to El Niño-driven drought and flood in Africa are among the world's most economically vulnerable. The Eastern African long rains, the seasonal rainfall that falls across Kenya, Ethiopia, Tanzania, and neighboring countries between March and May, showed an El Niño consistent pattern of failure earlier this year, contributing to drought conditions across parts of the Horn of Africa that were already experiencing food insecurity from previous climate shocks. Southern Africa faces the prospect of another El Niño-driven drought during the October to March rainy season. That is the foundation of agricultural production across Zimbabwe, Zambia, Mozambique, Malawi, and South Africa. The 2015 to 2016 El Niño produced the worst drought in southern Africa in over 30 years, triggering food emergencies across multiple countries and requiring international humanitarian assistance for tens of millions of people. The modeling for the 2026 to 2027 El Niño suggests a comparable or greater impact on southern African rainfall, arriving in a region whose food security situation has been further weakened by years of compounding climate, economic, and governance challenges. The global food system sits at the intersection of all of these regional impacts, and the arithmetic of what a Godzilla El Niño does to global agricultural production simultaneously across multiple major growing regions is deeply sobering. When Australian wheat production falls due to drought, global wheat export availability decreases. When Indian rice production is reduced by monsoon failure, the world's largest rice exporter has less surplus to sell on international markets. When southern African maize production collapses, a region that is already a net food importer requires even greater volumes of food aid. When Peruvian and Chilean fisheries collapse due to the disappearance of the cold upwelling that supports them, the global supply of fish meal, a critical input to aquaculture and livestock production worldwide, tightens. These disruptions do not happen sequentially, allowing markets time to adjust between shocks. They happen simultaneously, and their effects compound rather than average out. Global commodity markets are already beginning to price in the El Niño risk, and the trajectory of food prices over the coming 12 months, barring an unexpected and historically unprecedented moderation of the event that the models currently show no sign of, points toward levels that will be acutely felt by the world's most food insecure populations. The public health implications of what El Niño is about to do extend into territory that most weather coverage never reaches, into the epidemiology of infectious diseases whose transmission dynamics are tightly coupled to the temperature and precipitation changes that El Niño produces. Dengue fever, the mosquito-borne viral illness that causes several hundred million infections annually, and whose range has been expanding steadily as global temperatures rise, shows a well-documented association with El Niño in multiple regions of the world. Warmer temperatures extend the season during which the Aedes mosquitoes that transmit dengue are active, expand their geographic range into higher altitudes and higher latitudes, and accelerate the replication rate of the dengue virus within the mosquito, shortening the time between when a mosquito bites an infected person and when it becomes capable of transmitting the virus to the next person it bites. El Niño years are consistently associated with dengue outbreak years across South and Southeast Asia, Latin America, and the Pacific Islands. The combination of a strong El Niño and the background warming trend that has already pushed average temperatures higher than at any point in the modern era creates conditions for dengue transmission that public health systems in affected regions are genuinely struggling to prepare for. Cholera follows flooding and El Niño-driven flooding events, which will be affecting parts of South America, East Africa, and South Asia over the coming months, are among the most reliable drivers of cholera outbreaks in areas where water and sanitation infrastructure is inadequate to handle the contamination that flood events produce. The mechanism is direct and devastating. Floodwaters overwhelm sewage systems, contaminating drinking water sources with fecal bacteria, including Vibrio cholerae, the pathogen responsible for cholera. People who have no alternative but to drink contaminated water become infected. Without access to oral rehydration therapy and intravenous fluids for the most severe cases, cholera kills through dehydration with a speed that is shocking. A healthy adult who contracts severe cholera can die within hours of the onset of symptoms if treatment is not available. The humanitarian response frameworks that international health organizations have built over decades to respond to cholera outbreaks work when they can be deployed quickly enough and with sufficient resources. The challenge of deploying them simultaneously across multiple regions that are experiencing El Niño-driven flooding at the same time, with the logistical and financial constraints that the humanitarian system always operates under, is one that international public health officials are already planning for with a level of urgency that reflects how seriously they are taking the current El Niño forecast. The ocean ecosystems that El Niño disrupts represent another dimension of the coming crisis that rarely receives adequate coverage, despite its profound implications for human welfare. The Humboldt Current ecosystem off the coast of Peru and Chile, which historically produced more fish per unit area than any other ocean region on Earth, collapses during strong El Niño events, as the cold, nutrient-rich upwelling that supports it disappears. Anchovies and sardines that form the base of the food web have nothing to eat, and their populations crash. The larger fish, the seabirds, the marine mammals that depend on them follow. The fishing communities of Peru and Chile that have built their entire economic and cultural identity around this fishery face an abrupt and total loss of their livelihood, with no immediate alternative and no timeline for recovery that can be predicted in advance. The global supply of fish meal, a critical ingredient in fish farming operations and livestock feed around the world, tightens dramatically when the Humboldt fishery collapses, driving up the cost of aquaculture production and ultimately the price of fish protein in markets from Norway to Japan to the United States. What nobody's ready for, and what the title of this video points to with a precision that deserves to be unpacked rather than treated as hyperbole, is not any single one of the impacts described above. It is their simultaneity. It is the fact that the drought in Australia, the monsoon disruption in India, the flooding in East Africa, the food price spike in global markets, the dengue outbreak in Southeast Asia, the coral bleaching in the Pacific, the wildfire season in the American West, and the extreme winter weather in the southern United States are all going to be happening at the same time, driven by the same underlying oceanic and atmospheric shift, placing simultaneous demands on the international humanitarian response system, the global food distribution network, the public health infrastructure of multiple countries, and the emergency management resources of governments that are already stretched thin from the compounding crises of recent years. The world has systems for responding to regional disasters. It has frameworks for providing humanitarian assistance to countries experiencing food insecurity. It has protocols for managing disease outbreaks and coordinating international public health responses. What it does not have, what has never existed, and cannot be created on the timescale that El Niño operates on, is a system capable of responding simultaneously and adequately to the full spectrum of impacts that a Godzilla El Niño produces across every inhabited continent at the same time. The infrastructure vulnerability that El Niño exposes goes far beyond what any single government or international organization has adequately planned for. Roads and bridges built to handle the rainfall intensities of a stable historical climate are overwhelmed by the atmospheric river events and tropical rainfall extremes that El Niño amplifies. Water treatment facilities designed for the sediment loads of normal river flow become inoperable when floods carry volumes of debris that clog intake systems and overwhelm treatment capacity. Power grids, stressed by extreme heat in one season, face the additional burden of extreme cold outbreaks in the next, cycling through thermal stresses that accelerate equipment aging and increase failure rates at exactly the moments when reliable power is most critical for human survival. Agricultural infrastructure, the irrigation canals, the storage facilities, the rural road networks that connect farms to markets, suffers damage from flood and drought simultaneously in different parts of the same country, creating logistics challenges that stretch the capacity of national agricultural ministries to their absolute limits. These are not theoretical vulnerabilities identified in planning documents that gather dust on government shelves. They are the vulnerabilities that El Niño events have exploited in every major outbreak in the historical record, and they will be exploited again in 2026 and 2027 with a thoroughness that reflects the exceptional intensity of what is developing in the Pacific right now. This is August 2026, and the window for preparation is not closed, but it is closing. The decisions that governments, agricultural producers, water managers, public health systems, and individual households make in the next several weeks will determine how well or how poorly they are positioned to manage what the atmospheric data says is coming. Farmers who can diversify their crops, secure water storage, or access drought-resistant seed varieties have a narrowing window to do so before the planting decisions of the coming season become irreversible. Water utilities that can accelerate reservoir storage, repair leaking distribution infrastructure, or implement demand management programs have weeks, not months, to act before the drought conditions that El Niño brings begin to draw down their reserves. Public health agencies that can pre-position oral rehydration supplies, strengthen disease surveillance systems, and train community health workers in El Niño-associated disease recognition have a finite period before the conditions that drive outbreaks arrive. And ordinary people, the billions of people around the world who will experience the effects of what is developing in the Pacific without understanding what is causing the changes they are seeing in their weather, their food prices, their water availability, and their disease environment, have now, in this moment, the opportunity to understand what is coming and to take whatever steps are within their means to be less unprepared than they would otherwise be. Nobody is ready for what El Niño is about to do this August. That is the honest assessment of the data, the models, and the scientists who have spent their careers understanding these systems. But being less unprepared than you were before you watched this video, that is something that is still possible. And it starts with understanding that what is happening in the Pacific Ocean right now is not merely a weather story. It is the defining story of the next 12 months for billions of people across this planet. And it deserves exactly the attention, the urgency, and the respect that the ocean itself, the United Nations, and the scientific community are all demanding that we give it. The economic ripple effects of what El Niño is about to unleash extend far beyond the immediate sectors of agriculture, fisheries, and emergency management into the broader architecture of the global economy in ways that most financial analysts are only beginning to price into their models. Insurance markets are the first to feel the signal because catastrophe modelers at the world's major reinsurance companies have been incorporating El Niño forecasts into their risk assessments for decades and understand better than almost any other private sector institution what a strong event means for their exposure. Property and casualty insurers in El Niño sensitive markets in Australia, in the Gulf Coast states of the United States, and parts of Latin America are already adjusting their underwriting criteria, tightening their terms, and in some cases withdrawing from the highest risk segments of their portfolios in anticipation of the claims that the coming months are going to generate. When insurance becomes unavailable or unaffordable in a market, the economic consequences extend far beyond the insurance industry itself. Construction slows because developers cannot obtain coverage for projects under development. Property values in high-risk areas decline as the cost of ownership, including the self-insurance burden that uninsured property owners must absorb, becomes prohibitive. Mortgage lending tightens as lenders become unwilling to hold loans secured by properties in areas where insurance cannot be obtained. The financial system and the physical climate system are more tightly coupled than most people realize, and El Niño is one of the mechanisms through which the physical system transmits its signals into the financial one. The energy sector faces its own set of El Niño-driven challenges that compound the stress already being placed on power systems by the extraordinary heat events of the current summer. Hydroelectric power generation, which provides a significant share of electricity in parts of the United States, Brazil, Norway, China, and numerous developing countries, is directly dependent on the water flows that rainfall and snowpack provide. When El Niño brings drought to regions that depend on hydroelectric generation, the reservoirs behind hydroelectric dams draw down, reducing generating capacity at exactly the times when heat-driven electricity demand is highest. Brazil, which generates over 60% of its electricity from hydropower and which already experienced a severe energy crisis during the 2015 to 2016 El Niño, when reservoir levels fell to critical lows, is watching the current El Niño development with acute concern. The combination of reduced hydroelectric output and increased demand from air conditioning during El Niño-driven heat events creates an energy supply gap that fossil fuel generation, where it is available, can partially fill but at higher cost and with greater carbon emissions than the hydroelectric system it is replacing. The transportation and logistics systems that move food, goods, and people around the world are also more vulnerable to El Niño's impacts than is generally appreciated. River systems that serve as critical inland transportation arteries, the Mississippi River in the United States, the Paraná River in South America, the Mekong in Southeast Asia, experience dramatic changes in water levels during El Niño events that can render them impassable for commercial barge traffic during low-flow drought conditions or dangerously fast and debris-laden during flood conditions. The 2022 drought on the Mississippi River, which reduced water levels to the point where barge traffic was severely restricted for weeks, gave the United States a preview of the logistics disruption that El Niño-driven drought can produce in a critical agricultural export corridor. A repeat or more severe version of that scenario during the coming El Niño event would compound the food supply disruptions being generated simultaneously by production shortfalls in multiple growing regions, tightening the global food supply chain at multiple points simultaneously, and amplifying the price impacts that consumers around the world would ultimately feel. The mental health and social cohesion dimensions of prolonged exposure to climate-driven disasters, dimensions that are only beginning to receive serious attention in the scientific literature and in public health planning, are going to be tested severely by what El Niño is about to deliver. Communities that have already experienced multiple major disaster events in rapid succession over the past several years, the flooding, the wildfires, the heat emergencies, the droughts, are carrying a cumulative psychological burden that researchers are documenting with increasing concern. Post-traumatic stress, climate anxiety, ecological grief, and what some researchers are calling solastalgia, the distress caused by environmental change in one's home environment, are real and measurable mental health phenomena that are becoming more prevalent in weather-exposed communities around the world. The warning has been issued. The data is unambiguous. The trajectory is clear. What the Pacific Ocean is doing right now will shape the lives of billions of people over the next 12 months, and the time to understand it, prepare for it, and take it seriously is not tomorrow. It is today.